I like that. So if you guys run into an issue there, I don't mind. Go ahead and email me and I'll do the best I can here. Now, I've written myself a few notes here. Guys, you have the handout. I don't think we finished with that handout, did we? I think we were just, solving equations, I think, yesterday. Okay, I'm going to jump back into it now, but before I jump into it and try to finish that handout completely out, I have other handouts. Okay, I think this, after I do this, and maybe a little bit tomorrow, chapter 1 will be finished. It looks like we just met each other. And all of a sudden, chapter 1's finished. Okay, so it's moving that fast. What I thought about, though, we'll see, and you may have some concerns here. On part 1, I thought about this as you guys were doing things here. Part 1 is to solve an equation. You say, oh, professor, thank goodness, quiz number 1, just solving equations. I know how to solve an equation. And I thought, well, I may have selected these, I think, from that handout. One looks like this. And you guys who have looked at the handout, worked with the handout somewhat, I think that problem there was on the handout. Someone recognizes it. 2x squared is equal to 4x plus 1. What type of an equation is it? What should I name it as? It's a quadratic. And I should get what? 2 answers. Gotta get 2 answers. Now you have options. Now I may on the quiz tomorrow tell you which option I want you to use. But if I just say solve, it's up to you. You say, Professor, I can factor. If you can, go for it. Can I use a quadratic formula, Professor? Go for it. Can I use that crazy completion of the square? Go for it. Unless I have on the side there, please use a particular one here. Guys, on this one, to save me a little bit of time here, first let's put this in standard form and rewrite this as 2x squared subtract 4x subtract 1 is equal to 0. That is in standard form. Now, you guys who are with me and you follow me here, we have those options as to which one should I choose here. I'll tell you ahead of time, I don't think this one factors. You could try it, but I don't think it factors. So you may want to turn to option number 2, which is maybe I should try the quadratic formula. And if you're really, really ambitious, you could try what? Completion of the square. I'm going to jump in and try this by quadratic formula, guys. And I think, if I'm not mistaken, yesterday, we derived this. I think right at the end of class, we went through a completion of the square problem that was crazy and came up with this at the end of class. So guys, when I apply this, be very careful. If I apply here on this quadratic, being very careful, it's negative, and b in this case is a negative 4. Let's make a replacement. Plus minus square root b squared negative 4 squared. Subtract 4 times a, which is a 2, and c, which is a negative 1. And all that's over 2 times 2, 2 times a. Is that true, guys? Did I put the numbers in correctly? Is all that in there correctly? Negative b plus minus square root b squared minus 4 times a times c, all over 2a? Yes?
Wouldn't it be negative 2 since you're moving the 2x squared over?
Tell me again.
Wouldn't it be negative 2 for plugging in for a? Because it says 2x squared is equal to 4x plus 1, so don't you move the 2x squared over, it becomes negative?
I moved the other 2 terms to the left-hand side. Makes no difference. If you want to move this over right here and make it a negative 2x squared, go for it. As long as you get one side to be a 0. That's the issue. Yes?
You wrote in the green plus 1, and then you wrote in the blue minus 1.
Tell me again.
In the green, you wrote plus 1, but right below that, you do minus 1.
I thought I moved these 2 terms over. Oh, we're having issues already. I'm just moving terms over. I'm just getting one side to be a 0. Is that true, guys? Now, did I plug in the numbers correctly into the quadratic formula? Because you do a little partial credit as we move along here. Now, here's the big problem. Here's where I thought issues come up, is this part. This is where I've seen throughout the years many students, and some of my best, will mess up and try to simplify and see what that is underneath there. So guys, this becomes x is equal to, put it in black here, positive 4 plus minus square root. Now, it's messy underneath there. You gotta be very careful. I do know, you know that's right there, it's 16. This other, and I say other, I'm gonna block it off like that, this, a product of, I see a -4 left over, times 2, times a -1. And all that product, -4 times 2 times -1 is a product of what, 8? And I had what, 16 out front? So I got 16 plus 8. So altogether it's 24. All over, let's stick with the black here. All over 4. Gotta do this definitely tomorrow. Now am I finished? No, I was hoping that would be a square root of 25. So square root of 25 is 5, and I can go on and find other things happening here. Well, that's a 24. It's not perfect. But I got more to do with it. This becomes 4 plus minus, now this will take a little effort. Square root of 24 is not perfect. It's not 25, but can be simplified. Does anyone remember what square root 24 looks like if you simplify it? And I'm thinking 24, maybe that's what, to give you a hint, 4 times 6? Is that 24?
Yeah.
And I think that 4 is what, a perfect square root? It is a perfect square root. It's what, 2?
2, 6.
Yeah, there you go. So we can write this as 4 plus or minus 2, radical 6, all over still 4. Now you get ready to turn your paper in. Nope, don't turn that paper in yet. I see, and I'm going to circle and see if you guys recall. This tells me, those numbers I'm circling, this one can be reduced down. And what number can I reduce all those numbers down by? 2. 2. We're going to divide each one of those circle numbers down by 2 to reduce this down. If I go through and divide everything by 2, guys, of course we get a 2 here, 4 divided by 2. This is nice, it gives me just 1 square root of 6 all over 2. Do we agree?
Yeah.
I'll accept that. I'll accept that as an answer. Those are my 2 answers. Now, if though, on the top where I say list them, of course you would say, well, Professor, no problem, I did all the work. I can just separate them. One says 2 plus radical 6 over 2. And the other one is 2 minus radical 6 over 2. And there it is done. Why not? Why not? There you go. That's one type you could see tomorrow. Now, with that said, but do slow me down points here. Part E. I think you guys are telling me you agree with this one. Also, I noticed, maybe, hang on, oh, I did, this one. X cubed is equal to 16x. Solve for x. Okay. How many answers would you expect the way it looks? 3. I'm expecting 3 answers. Any ideas how to get started? Yes. Okay, make the equation equal to 0. Thank you, like I did that last one. I'm going to just merely move that 16x over, not subtracting, to the other side. I'm going to get my 0 that, like that. Now keep in mind, I'm expecting 3. They call them zeros, answers. Now what? There comes your factoring skills. Do those 2 terms have a common factor? First, do they have something common? Yeah, an x. So if I pull that x out, that common factor, being very careful, I end up with this. I think. Now, if your factoring skills are strong, am I finished? This right here, and someone give me a phrase that you use somewhere. What type of an expression is binomial, but what type of an expression is that? Yes?
Is it a 16x squared? The question.
I took the x out.
No, the
No,
problem
the
is x would equal 16x squared. Like the original problem.
Here's the original problem.
Yeah.
Yeah, we moved 16x over and took out an x.
On the word
No,
sheet.
on the sheet
on
it's
the worksheet.
different.
On the worksheet says 16x squared.
Oh, no, I changed it.
Oh, you changed it?
Oh, I changed it for a reason. Oh, you got excited. Okay. Now, for a reason I changed this. Now, we finished? No, right here, guys, this will break on down. And many students will recognize this as something you've heard before. This represents a what? Difference of squares. In fact, let's see, an x being squared, and what's squared here, 4?
Yeah.
So I could easily, with the difference of squares, call this quickly x plus 4, x minus 4 is equal to 0. Now, has it been factored completely? That's done now. Now, what should I do now to get my 3 answers I'm searching for? What's the easiest part of this? Yeah, we'll set each one of these factors equal to 0. So 0 product progress. So if I am patient, and I do this, definitely one answer is 0. This one, if I solve the one in the middle here, solve for x, you get a -4. I solve the one on the end, you get +4. Do I have 3 answers? Finally? If I list those, my answers are 0, -4, 4, and we're finished. How's that look? That's just a sampling of equations, types of equations you could see on that quiz tomorrow. Maybe a quadratic, and I may and I should do this also. I don't know whether I'm gonna have time, but I should go back and redo this one just for a little practice. Redo it by completion of the square. Should get the same answers, just in case I ask you to do one by completion of the square. Just be a little review. I thought I saw a hand go up. Go ahead.
Yeah, does the order matter?
It does not.
It's not.
This right here does not.
Oh no, I mean like over there, like where the arrow is, like below that.
Oh, you mean you want to put x minus 4 first and x plus 4?
Yeah, does it
No,
matter?
no, of course not.
Oh.
No. Yes,
I can't really see from here, but you say doing completion of a square like a cubic?
we're going to do a completion of the square on this one, the quadratic.
Oh, the quadratic.
Okay, part C. Hope I have fun with this. I'm going back just for a little practice. Lots of things going on here tonight besides this. Now I'd like to redo it, and all of a sudden this time not quadratic formula like I did earlier. Complete the square. And that's a process that you've got to be very careful with. Guys, I would suggest, yes, you can move everything over, make one side 0, that's no problem. Like I did earlier, you can do that easily. Now, can someone remind me of what I gotta be careful with if I want to complete the square?
It has to be the leading coefficient.
The leading coefficient's gotta be a 1. Okay, so let's divide everything by 2. Get that leading coefficient to be a 1. Now, guys, when I divide everything by 2, don't let me make a mistake. I get x squared, subtract 2x, subtract 1/2 is equal to 0. That's arithmetic. Now, she's asked me to do that, and sure enough, now that leading coefficient is a 1. Now I can start my business, which is complete the square. Now, to complete the square, to see what I need to complete, let's leave those x terms where they are, and show, I like this when I put a blank here, that shows I need to complete it. Let's move that 1/2 over, let's keep this balanced, blank again. Now, how does one determine what is required on that blank? In fact, I think yesterday I recall some student gave me some crazy number and it worked, and other students were looking and said, where did I get that number?
D divided by 2.
Thank you, take that D, or that middle coefficient, that coefficient of the x, the middle one there, and divide it first by 2, take 1/2 of it. So that's right like this, which really is -1, then put a comma. What does one do with it afterwards? Because I'm not gonna place -1 on the blank. Yeah, you do take 1/2 of that middle coefficient, and now take half of it, what does one do with it to find what that number should be on that blank? What did we do yesterday?
Square.
u squared. Take negative 1 u squared. Well, put the comma there, which turns into a positive 1. So after all that, we hope that this, use a red here, is the right number. We hope. Now, we'll at least, in hoping, we'll at least all this on the left-hand side factor into, and that's why they call it completion of the square. Is it a nice perfect square? If I should right here do it, factor it on the left. What would all this factor into? Anyone? This should be a perfect square. How much? What does it look like? Is it x subtract 1 quantity squared? That's what I want. The entire left-hand side is just x subtract 1 quantity squared. The other side looks going to be a little awkward, not too awkward. It's up here. 1/2 plus 1. Well, what can I say about 1/2 plus 1 from elementary school? 1 1/2? Maybe better expressed as 3 halves in the problem here. 1 1/2, 3 halves. Is that true? Okay. Now, we're down to there. That's like the next step. Now, what would you suggest? I got to solve for x. What's the next step in this, in an attempt to get the x? Take the square root. Actually, I heard that. So if I attempt this on both sides, let's see what we're going to end up with here, guys. On the left, that's the easy one. That's x subtract 1. How many answers am I expecting? That's when I prefix this with plus minus. That's the only reason I put plus minus, to ensure I get 2 answers. Now that's awkward as you know what. That's why I brought it in. The square root 3 halves. That's what it is. Is that a perfect square root? Well, it's nowhere near perfect. Does anyone help me? So I brought it in tonight. What would you do for a square root 3 halves? I know what you do with a square root 25. You'd say, Professor, 5. Square root 49, 7, Professor. Square root 100, 10, Professor. Square root 3 halves? Come on, remind me. What should I do?
Square root 3 over square root 10.
There you go. Thank you. Awkward. But he's giving it to me. He said, Professor, separate them. But then if you separate them, there's a rule back in math that you cannot leave, they do not want us to leave a radical in the denominator. They call it rationalizing. So how can I get rid of that square root 2 in my denominator, which I do not want to stay there? Who recalls how to get rid of this? Yes? Go for it.
Multiply by 1, which is like square root of 2 over 2.
Okay, radical 2 over 2. That's what I'm hearing. Multiply this by radical 2. If you do it there, you gotta do it here. Now, by the way, that radical 2 he chose to give me, will that, when on the denominator, the bottom part, this becomes now radical 4. Is that perfect? Thank goodness, it's a 2. So that helps me there. On top, of course, radical 6, which is not perfect, but it's radical 6. The guys who put all this together, we go back. At this point, we have x subtract 1 is equal to plus minus this business. At this point. Now to get the x completely by itself, what should I do next? I want that x completely by itself. What? Move the 1 over and have 1 plus minus radical 6 all over 2. Now, you got to keep in mind, we're supposed to get these answers again. Same problem. What might you suggest I do here now to maybe clear this up a little bit and make it look somewhat better? Okay, here's something.
Turn the 1 into 2 over 2.
Thank you. Maybe a common denominator of 2. Wise. He says, Professor, think of that 1 out front as 2 over 2. So these terms now have the same denominator. And rewrite this as 2 plus minus radical 6 all over that common denominator of 2. Lengthy as you know what, crazy as you know what, did it lead me back to these? Did we get the same answers? But this time we did it by completion of the square. Now guys, that's my little recap on solving equations. I see some looks over here like, whoa, whoa, professor. Okay. Any concerns there, guys? How to solve an equation? Okay. Go ahead.
Oh, how'd you get the 2 again? Like at the bottom?
Right here. Right here, this 2? Right here?
Yeah, how'd you get that?
It was originally a 1.
Yeah.
He says, being wise, right, 1 is 2 over 2. That's still 1. So these match up.
Oh, yeah.
Therefore, we can put everything together with a common denominator. Yes?
Where did you get the 3 over 2 from?
I add these 2 up.
Maybe you had to,
I think 1/2 plus 1 is 1 1/2.
Yeah.
I changed it to 3 halves. It's a fraction. Yes?
Yeah, maybe I didn't see. How do we get from a, like, 3 over 2 to a 6 over 2? Because we're at 6 over 4 now.
Oh, right here, radical 3 over 2. A student told me, he said, Professor, this is not perfect, nowhere near perfect.
Yeah.
He says, but I think you can separate them. Radical, the numerator, radical, the denominator. So I did, I separated them. And then there's a rule in math that they do not want a radical remaining here. They want to rationalize it. So he asked me to multiply top and bottom by radical 2. And this gives me a 4, which is perfect, it's 2. And this gives me a radical 6. Okay? But you know what? You asked me a good question. Who on earth, if I walk up to you after class, and if I see you after class, by the way, I do ask my students questions. I've met many of my students out shopping. We're out doing something. So if I see you in a store and you're out there shopping, I say, wait, I recognize that student. And you'll recognize me. If you come up, if you want to say hi like that, move on. But if you want to come up and chat, I got a math question for you. Right there in Walmart. I'll ask, yeah, where are you shopping? I'll find you. I tried that with 2 guys who were parking in the parking garage one day. I was parking in the parking garage, they were parking. But they were on the upper level. I was put down here, and I heard my name, Ramsey. I said, oh, guys, come here. We'll see you later, Ramsey. Had been class, and they usually came to me, I was going to have a couple questions. Now, his concern though, guys, look at this. Who on earth, me as a professor, this and this look so different, don't they? Square root 3 halves is equivalent to square root 6 over 2. No way would someone think those 2 are the same. They are. They're equivalent. Guys, anything else on this? Yes?
So let's say like there when you're doing 3 over 2, instead of like saying like 1 and 1/2, when you say 3 over 2, you say like 1.5. Would that like mess up the
That would. With the decimal, it would.
It
It
would.
would. You don't have a square root of 1.5. They're 1 decimal. No decimals. Guys, anything else? Okay. So I'm getting a sense of, this is our second meeting. Boy, we had better get ready for that quiz. It's short. 35 minutes. It's very short. I think I have only 3 problems for you to do in 35 minutes. Equations, equations, equations. I want to make sure you understand how to solve an equation. Okay, and this is just sampling here. Okay, we'll leave this. Part 2. Now, remind me on that handout, and Mr. Park sent out all the answers. And by the way, you got to keep in mind, Mr. Park is a math person. He's had all these math courses here, and he's going to be leaving us pretty soon to go to school elsewhere. So he may approach it a little differently. He'll say, how did you get that answer? So he may be using something we're not using right now. But was there a section on this handout with inequalities? So I need to take a look at some of those. This. And guys, that's working with these symbols. Inequalities, not equations, inequalities. And I know by now in your math here, you realize this. This reads as greater than. The second symbol for an inequality, less than. Greater than or equal to. less than or equal to. That's no problem. That's what those symbols represent inequality. What we need though, in the math, and the higher math you go, they use these symbols. I need to represent this, and this, and this, and this, in something known as interval notation. I know what symbols. I'd like to express what's going on here using something known as interval notation. Now, with your help, I'm going to use my first symbol here. Let's say x is greater than, I want to give you an example here, x is greater than 5. That's just a sample, using the symbol. Does anyone recall what that might look like using something called interval notation, which we use in higher math for sure? I see a hand going up, yes?
You put parentheses on both of them.
Parentheses,
Yeah.
okay, and 5,
And an infinity sign.
the infinity symbol,
Yeah.
and then close that up with the parentheses. That says x is greater than 5. 5 through infinity. If I use a less than, let's make this x is less than, guys, here goes, let's say -3. How might that x less than, everything less than -3, look using this so-called interval notation? Who has an idea? I see a hand go up, yes.
It's parentheses and then negative infinity. And then comma and then -3 and then parentheses.
There you go. That's what it means. Now, before I jump into and try the others, let me go back to that x is greater than 5, just in case you have not seen this for a while. Hang on just a second. X is greater than 5. If you visualize what this means, guys, here it goes. Let me place 5 right here. This is a visual of what this might mean. This means don't include 5, but everything bigger than 5 can be used. In other words, you're shading, if you should shade this, just make it a little darker, a little heavier. You're saying, Professor, x is greater than 5 means this section of the number line, which can be written like that. And this corresponds to this. This is, they call it interval. The other one was x is less than -3, and he just gave me what I wanted to hear. But a visual here, you're down at -3. Again, you're not going to include it. And this says everything less than, to the left of -3. This time you're looking at, make it a little heavier. All this to the left of -3. And guys, this and this mean the same thing. Everything to the left of -3, negative infinity up to a -3. Now, I'm throwing one more. And we use one of these symbols here. Let's try the greater than or equal to. Suppose it looked like this. X is greater than or equal to, it's read as. Let's try maybe 4. Does anyone recall, easily done here, what that might look like in this so-called interval notation? Nikki?
I think you have to, for the line, I would say you have to go dark circle.
There you go. She says, Professor, if you want to visualize it first, she says, start out with 4, and this time you get better, not place an open circle, you better close it in. I see an equals mark says it could be included, so this time it's darkened in. And which side should I shade in to show greater than 4?
The right side.
Of course, just make that a little heavier. Like that. Now, how am I going to represent this like this in interval notation? I see a hand going up, yes.
Isn't it a bracket and then 4, comma?
Thank you. So you say 4 with a bracket, then all the way through infinity goes forever, and infinity is always with the parentheses. So that bracket goes around the 4 to show the 4 could be included this time. That's what they're discussing when they say place your answer in interval notation. Okay? So I have not tried any of the problems yet. We're going to express the answer though using interval notation. Now with the handout, and who has a copy of the handout? Because I need someone to start reading for me some of these inequalities. Yes, would you read for me What was the first one there to solve on the inequalities?
2x minus 2 is greater than 3 plus x.
Greater than 3 plus x? Like that. There, we just solve this. You solve these much like equations. And this one's easily solved. You start moving terms around. Guys, when you start moving terms around, please tell me, do I end up with, real quickly, x is greater than 5? Yes or no?
Yeah.
I just move things around like I would an equation. Now though, since it's not an equation, they want now the answer expressed using an interval notation, and I think I did that one earlier. Is it this one? Is this the interval notation representing this answer? So from 5 with the parentheses, 5 through infinity, and there's your answer. And you're finished. Now, would you like to see on the quiz tomorrow lots of these like this? Sure. Yeah. Are you going to see lots of these like this? No. No. We'll get more interesting ones. Okay, tell me the next one.
Negative 2, quantity n plus 3 is less than 8.
Less than 8?
Mm-hmm.
Gotcha. This one's not too bad either. Much like an equation. I'll use the distributive property first. If I distribute the negative 2 that she gave you, you're going to end up with negative 2n. Looks like subtract 6 is less than 8. Look how easy that is done. Move that 6 over, add it. You're going to end up with a negative 2n. Looks like it's less than 14, if my math is correct. Divide by negative 2. Looks like the steps are pretty easy so far. Now, when I divide by negative 2, definitely need to cancel here, n. Does anyone recall on inequality something you had to watch out for way back? If you divide or multiply by negative, yes?
Switch the side.
Yeah, the symbol's going to switch on you. So this becomes not less than, but greater than. And of course, 14 divided by negative 2 is negative 7. If there's no mistake, there's your answer. Now, what does that look like in interval notation? Parenthesis, negative 7 through infinity. Done. How could you go wrong? Just like I told you yesterday, if you go wrong in this first quiz and write on your paper, you went wrong. Nah, don't do that. We don't go wrong in this first one. Read the next one for me, please.
4 is less than or equal to 2x plus 2 less than 10.
Now, this one's interesting. This one's called a combined inequality. There's 2 of them to worry about. Now, I've had some students say, wait, Professor, if there are 2 of them, could I separate them? Sometimes separation will do it, and you could separate them. Now, I'm not sure what the separation would look like. They are combined right now. There's actually 2 problems in one here. If you separate, here's one of the inequalities. 4 is less than or equal to this. Now, then we use the word and. I see another that I can separate. This marker will work for me. Here's the other one in the black. So 2x plus 2 is less than 10. Now there they are separated. Those are the 2 I just took out and separated. I can solve each one now independently. Which that first one I think will be. Hang on.
We can also treat them as like the
No,
same.
I'm not doing that yet. Hang on, I don't know what you're going to add. Okay, the red one, guys, no problem. Now this red one, tell me, I know it's turned around a little bit, but if I want to solve it, tell me a way to solve it. It looks simple. How would you find the x? I could move the 2 over, maybe, right here. You end up with 2 is less than or equal to 2x, that's no problem. Then divide by 2, you end up what? 1 is less than or equal to x. Now it looks a little strange because the number's on the other side. Usually you like to have the x on the other side. I could easily say, wait now, this means this also if I would just turn it around. Are these 2 statements saying the same thing?
Yeah.
If 1 is less than or equal to x, just turn it around and say x greater than or equal to 1. And most students prefer to get that x on the left-hand side, which is good. Now the other one over here, oh, it's easy. Here, this is 2x. I'm going to move that 2 over, subtract it, and get an 8. divided by 2, x is less than 4. I hope I didn't make a mistake there. Is that true? That's the separation. But you got to keep in mind, originally they were together. So I got to put those two answers back together. Okay, so together I've got a visual here going on. Here it is. This is me thinking about what it looks like. It says x is greater than or equal to 1. Here we go, 1. I'm going to darken this in and show in the red, if you don't mind, a little heavier, this. This all shows, and it goes forever, x is greater than or equal to 1 in red. I'm going to use a blue here to show the other one, x is less than 4 on the same number line. So go up to 4, open, and to show less than, we'll shade in up here so you guys can see it. That means in the blue, it's going in that direction. Is that true? Now, where do they overlap? What do they have in common? Does the blue and the red overlap somewhere? If so, that's the answer. That's what they have in common. And guys, looks like, if I'm not mistaken, it's from 1 out to 4. If it is, just visually here, that's the answer. So in the interval notation, it looks like maybe bracket 1 up to 4. Should 4 be included? Open. Now, this student says, wait, professor, did you really need to go through all that separation business? I see what you did. Because I think you could have just left it like you originally gave it to me, combined. And look at this. I'm getting clever. Here's the way it was originally given to you. And you're trying to solve for x. He's telling me this. I guess, professor, separation's good, but why don't you just do this? Subtract 2, subtract 2, subtract 2 on all 3 parts. And make this quickly here, I guess 2 is less or equal to what? 2x is less than 8. And then what's my last step if I'm seeking the x, find the x by itself? Divide everything by what? 2. Thank goodness that 2 is positive. No symbol reversing on me. So 1 is less or equal to x is less than 4 without the separation. Please tell me, are these two saying the same thing? But you could have left it like you said, combined first without separation. Okay? Sometimes, though, it's so awkward, you have to separate. So that's why I showed you the separation just in case. How much more do we have there on that?
A few more, like 4.
Okay, like number 4, what's number 4?
0 is less than quantity 4 over y less than 2 over 3.
Now, I looked at what Mr. Park sent out to you guys. He gave the answer. But you gotta keep in mind, this guy's a mathematician. So sometimes he's been around this a long time. Sometimes I'll sit down and I'll do something really crazy. My students say, Professor, what'd you do? And I finally catch myself, whoa, I did something that maybe they're not aware of. So I saw what he did, which is nice, beautiful. Guys, this guy told me, on the last one, says, Professor, leave it combined, because I have another combined, leave it combined and solve it, and I did, and it worked out to be the same as when I separated it. Can I, on this one, leave it combined? And so if you want to leave it combined and don't do a separation, what would you suggest I do? Because we're trying to solve for y here. What would you suggest I do? If I leave it combined. Go ahead.
Multiply everything by y.
And why can I not multiply everything by y? That's exactly what I would say as a student. Why in this case can I not just go through and multiply everything by y? Because he said, wait, Professor, go ahead and do it. Because when you multiply this right here in the middle by y, y's cancel. You get a 4. Of course, this stays 0. And this becomes some strange thing when you multiply by y. Why would you not want to multiply by y? Give me a good rationale on this one. That's something else. I think you're getting close to what I want to go. Why would you not want to multiply by y? Because I'm more than likely as a student I would.
0.
No, there's something about that y. Something going on that you should not do it here. Yeah, y could be zero. And you know you can't let y be zero up there, that'd be a zero denominator, that's undefined. But another good reason why you would not, so tempting, just go through and multiply everything by y, clean that up, and then solve it. What's wrong with that? Yes?
Can we solve the inequality like equality, and then we can determine the sign?
Oh, got you. Okay, you're going right to where I'm gonna go shortly.
Yeah.
Hang on to that thought. Something else though, because you want to have a good rationale at this point why I cannot do, which I'm telling you is so tempting. Why can I not do this? Professor, just go there and multiply everything by y. Everything, just straight across. You want to tell me a good reason why? Stay with that.
How are you showing
Let me get it.
the visual one?
Oh, it's something, yeah, something else. Oh, no one wants to be exempt from the quiz tomorrow. Oh my goodness, yes.
Because it has to be greater than zero.
Okay, do it again.
Because it has to be greater than zero, and we multiply if y is zero.
Okay, I think she's telling me this. If I multiply through it by y, do I know what y is? Suppose y were negative. And I go through and multiply everything by y and it's negative. What's going to happen? Those symbols are going to reverse. Since I don't know what y is, that's what we're trying to find. Suppose y is positive. If I multiply everything through by y, if I'm assured y is positive, that would be good. Nothing changes. Is that true, guys? So if you multiply by a negative, I'm going to have to go back up there and reverse those symbols. Multiply by positive, I'm good. But I don't know what y is. Is it positive? Is it negative? Should I reverse? Should I not reverse? We don't know. Over here, I didn't have that problem. Worry about it. This one I do. Now I'm hearing someone tell me, I think, Professor, don't do that. If you don't know what y is, those symbols may reverse on you. We're going to separate this one. Bear with me. First one separated, looks like this. Which does not look bad. That's the first one. Then and the second one looks like this separated. So you guys agree? Is that the separation? Is that it? Just torn up into two pieces. Did I do it correctly, guys? Now, let's get this one out of the way. What on earth would you suggest I do here? Now, I think Mr. Park did this on the solution he sent out. I still can't multiply by y. Because I don't know what y is. Even on the little symbol in there. I can't multiply by y. That symbol may reverse on me. I don't know what y is. Y may be negative. You say, oh, Professor, make it easy. I see a hand going up. What would you suggest I do here?
Cross multiply? Oh, the other one, sorry.
Oh, over there. You want to do something over there. How about this one? Zero is less than 4y.
Y just bigger than zero.
Oh, got you. You tell me, okay, hang on, just a thought here. 0 is less than 4y, you could leave it like that. You're saying, Professor, it's going to be a little awkward. But does this mean also, if I wish, could I turn around and say that, are these two statements saying the same thing? In essence, are they saying the same thing? If 0 is less than 4y, does that imply 4 over y? Does that imply 4 over y must be greater than 0? Just turn around. Okay? Now, since I can't multiply by y, I still can't multiply by y, even if you think of it like that. A little common sense. It says 4 divided by something, I'm looking for that something. It's going to give you a positive answer. Greater than 0 means positive. Can y be negative? I now can rule that out. Y cannot be negative, can it? If y were negative, this becomes 4 over a negative number, this entire result would be what, negative? Now I want the result to be greater than 0, which implies what? Positive. Does that mean my y must be also positive? So now I know what y is, it's positive. Can I now multiply by y? Am I sure it must be positive? Okay. And since I'm looking for y, can I just on the side here, I think Nikki's telling me here, Professor, just go ahead and put it down here. Y must be positive. That part's done. Does everyone see why y must be positive here? Which is y is greater than 0? The only thing you can replace y by is a positive number. If you expect this 4 over it to be also positive. So we got that out of the way. Why? That's done. The other side, oh my goodness, this is a tough problem. If you looked at it, you think, Professor, really, that looks so simple at first. The other one here in the black is 4 over y. I'm gonna move that 2/3 over, guys, for a reason. Less than 0. And I know what that less than 0 means. That's why I moved that 0 over there. Move it over to one side, have one side 0. That less than 0 means negative. Now, can anyone tell me how or what should I do to approach and get the answer for the second part? This is the hardest one of all of those, I think, on that list. Even though it looks so simple. Let me get. Sorta. Not quite. This one's tougher. All we have right now established is Professor y is greater than 0. I think if you look back at Mr. Park's solution, that's what he finally came up with. Y is greater than 0 for sure. But I'm not quite finished. Now, what am I going to do with this part over here? And I did move the 2/3 over. Guys, could I combine those two terms with a common denominator? That might help. Can anyone tell me real quickly what those two terms look like placed over a common denominator?
3y.
And what is my common denominator in the first place? 3y. This might help. If it is 3y, we know how a common denominator works. This is got to multiply, or has to be multiplied by 3, and this is got to be multiplied by y. So we end up with what? 12 subtract 2y is less than 0. Let's put the two terms together. Woo! Now you got to solve that. Mr. Park, any suggestions? I saw your solution, which is beautiful. But we got this sort of established already. This part's done. Y must be greater than 0. Now we're trying to get this part, and we have it down to here. We're not quite finished yet. Go ahead.
If you look at the fact that y is greater than 0 on that part, does it apply to this part, or is that the whole other equation?
Beautiful. Y is greater than 0 just for this part here.
Only for that?
Yeah.
Okay. So here we don't.
But you know what? Good question. Nikki says, if you've already established, Professor, y is greater than 0, could you just not go back to where we first started and say, now it should be okay to multiply everything by y? Have we already established y is greater than 0, which is positive? So if I multiply everything by y and establish, and maybe not have to go here, certainly. Nikki, here we go. If you multiply everything by y now, up there, don't make a mistake. All those terms of y in the original loop here. Of course, we get 0 is less than what? 4? Is less than, I gotta multiply this also by y. What would that look like? 2y over 3. Not enough 3y. Multiply by y here, be careful, that's like y over 1. So it's 2y over 3. Now can I multiply everything by 3? Is 3 positive? So I have to worry about symbol reversing. Can I multiply everything by 3? If I multiply everything by 3, guys, but I now end up with this. Yes or no? Now what can I do and attempt the best I can? What? Boy, this is looking messy. What can I do now? What do you think at this point, if this is going to work, what can I do now in an attempt to finally get the answer? And Nikki guide me into this, and we're going to see if it works besides me separating over there. Could I divide by 2? Would they at least get the y by itself? I know that y is on the end, which is awkward, but divide by 2, guys, please tell me, do I get this? Now, it's messed up, but that's what it looks like. What does that mean? What y have to be here for that statement to be true? Nikki, I tried what you did there. I don't know whether you want, I know zero, by the way, is this part right here true? Is 0 less than 6? At least that part? Now 6 is less than y, and on that 6 is less than y, the end part, the first part's true. 6 is less than y. Guys, can I turn around and say that y must be greater than 6? They're saying the same thing. Can I just quickly say this? Are those two saying the same thing? Awkward, but Nikki, look at this. If I say y is greater than 6, if that y is greater than 6, like a 7, would this entire statement be true? 0, still less than 6, is 6 less than 7? If I put an 8, is 0 less than 6? Yes. Is 6 less than 8? So must that y on the end be what? Greater than 6? I think Mr. Parker approached something like that. I don't think he went through all this business where I was going to go through and separate this and go through. Look at this, guys. By the way, do you see if I finally divide up here by 2, you get a 6 coming in? 12 divided by 2, even on this part of here. If I should go ahead and finish it up. Awkward as you know what. Now, I'm going to leave it right here. You're going to go through and say, Professor, I want you to separate like you did and go through this business and put them back together and see what you get. And I think you're going to actually finally get, as we did here, guys, final answer. She gave me the problem is this. Okay, we already said this. She says the original problem on the handout was that. Answer looks like is that what we discovered? Which in interval notation is? So that on the end there that she wants me to do must be greater than 6. To satisfy this statement. Mr. Park, did you check? And I think that's what you did. Final answer I think was greater than 6.
I forgot.
You forgot. Or 6 through infinity.
Yeah.
Yeah, I think I checked your work. I think you got the same answer. Without going through all that business. Wow. Now, that one took a little time. What's next?
X squared minus 3x minus 10 is less than 0.
I've been waiting for this. We've got to know this. We got to know this. Hang on a second. Okay, tell me what that was and I'll jot down. Number 5 there was, again, x squared, what was it?
X squared minus 3x minus 10 is less than 0.
Like this. Now, a student was telling me earlier, and I told him it was a good thought at that time. This is where I'm going to start using what he suggested earlier. Guys, this one takes me back to a quadratic. Factoring. This is the first one I've seen a quadratic with an inequality. It's a quadratic inequality. They're both together. If it factors, I think it factors, and you guys should know how to factor by now. Does it factor into x subtract 5 times x plus 2? That's the way it factors. Yesterday, and maybe today you saw me doing this, I think the next step would be, say, Professor, I like my factoring, I did my factoring, can I now split them up and get this? We did this yesterday. We used what was called, was it zero product property? And we got answers out of, in this case, the answers would be this. Now watch carefully. I've been waiting for this. Now, am I finished? Tell me what, I'm not finished. Tell me why I'm not finished at this point. What have I just discovered? If you walk out of the quiz, and let's say you saw something like this on the exam Friday. You saw something like this on the exam. You say, oh, I feel good about this, Professor. I got 5 to negative 2. You would feel good and would be correct if this had been the symbol. It'd been equals. You'd be 100% perfect. It wasn't. So I got a 5 and a negative 2, and I think the original inequality symbol was what? Less than?
Less than.
Professor, then you're asking me not to just get those numbers, you're asking me to write in interval notation, because I see an inequality symbol. So that means there must be an interval of numbers that'll satisfy this, not just those two numbers you have right there. Now here's what I want you to get accustomed to. It's a message some of us may have seen. I'm going to use those numbers. I'm going to go to a number line. Like a visual here. I'm going to place those numbers, -2 and 5, for a reason. I'm going to place those at least on the number line. By the way, guys, I know she gave me, when she read this to me, less than, not less than, or equal to. So they are open, not to be included. Watch carefully. There they are, open. Now, I know I must shade somewhere. I must shade somewhere, because I've got to find which intervals work. Now, it might be all these numbers to the left of -2, I don't know yet, that will satisfy what she gave me originally. It may be everything caught between, I don't know yet. It may be out to the right of 5 through infinity, might be the numbers that will satisfy this original. What are we going to do in math as you move into the higher math? Remember, say, go ahead and approach it like this, get your numbers, but now you got to choose a number in each one of these intervals to see which ones work of your choice, and we're going to test it. Now watch carefully. I don't care what you try out to the left of -2, that may work, but you got to give me a number to test. Guys, you can give me -10, -3, -100, as long as it's to the left of -2. I'm going to try maybe -4. I'll come back to it. In between -2 and 5, infinite number of numbers you could try. I don't care which way you try. I'm going to try 0. Out to the right of 5, here I'm going to try an 8. Let me write this as x equals. And you say, wait, Professor, this will take forever. Are you telling me those numbers that I get to select, of my choice, in each one of those intervals, you're asking me to take -4 for an example back up here and replace all these x's by -4 and crunch it out? No. You could. No. Make it easier on yourself. Go to the factored form, watch carefully, and replace the x's by -4 in that factored form. Well, a -4 subtract 5 is a -9, I think, isn't it? It's a -9. I'm just concerned about the sign in this case. So I know it's negative. I'm not concerned about the 9, but it's negative for sure. Right here, it's negative, put it in red. If I put a -4 into my second factor, -4 plus 2 gives me what? -2 gives me another negative. So those two factors are guaranteed to be negatives. I don't care about the numbers, it's the signs. Now what is a negative times a negative going to give you altogether? It's going to give you a positive. So out to the left of -2, we just determined everything's positive. Is this symbol here telling me that's what I was looking for? What does less than 0 imply? I'm looking for a what? A negative. I can't use that interval then. The one I just tested gave me a positive. The problem she gave me says, no, Professor, you're looking for something less than 0, which implies you're looking for a negative. I can't use it, even though I went through the routine. Well, maybe in between works. I'm trying 0 for my choice. If I put a 0 in there, 0 subtract 5 gives me a negative, -5. 0 plus 2 gives me a positive, +2. And a negative times a positive, last time I checked, is a negative. Is that what I was looking for in the original? Did it say less than 0 in the original, implying what? It's negative? So with that one little check, all these work. You said, Professor, suppose I had chosen a number different than 0. You chose 0. You could have chosen anything between -2 and 5. You're going to finally get the same result. Any number. Out to the right, I doubt if it works, but I'm going to try it. I'm going to try 8. I tried 8. Put 8 in. 8 subtract 5, and my first factor is what? +3. And 8 plus 2, I guess, is 10. +10. And that gives me what? A positive which I cannot use in this particular problem. Now, with all this, put a comma here. Can someone tell me, based on this, what's my answer? In interval notation, what's my solution to that problem she read out to me? Go for it.
It's gonna be, parentheses, -4, no,
Not negative.
-2, and then 5, and then parentheses.
Perfect. There's your answer. There's your answer. I love these where they have you to do this, where they ask you first find the numbers, place them on a number line, and test. And whatever will the check come out to be, that's where your answer is located. I saw a hand going up, yes.
What if you were to graph it?
You can graph it.
You graph it and you wouldn't have to plug in any.
No, we're not to that graphing yet.
Okay,
We can certainly graph this. You know what this graphs into, don't you?
yes,
What is it?
it's a problem.
It is parabola. Yeah, later on we'll graph. Absolutely, you're right. Later on, but right now we're gonna use this little process. Now your textbook gives a name to this. If we want to use this, you say, Professor, do what? Factor, test numbers, numbers of your choice, find what works, and then that's the answer, and makes it very, very easy for you. They call this process sign analysis. Sign analysis. You're looking at the signs. You're doing an analysis on the signs. See if it works. Now, that one's finished. How many more are there?
There are 2 more.
Okay, so we're getting carried away with this. But read the next one. I may change it something else, but read the next one.
X squared is greater than 4x.
Beautiful. I need that. X squared is greater than 4x. Now see why I did this on the handout. Okay. I will do this. Tell me first what you might, as a student, think to do.
Square root both sides.
Let me again?
Square root both sides.
Yeah, anytime you see a square, say put a square root. I like that, but even the 4 she gave me, that's a perfect square root. But I would, as a student, say, place a square root on both sides, Professor, which might lead you partially to where I want to go. There's definitely nothing wrong with taking a square root. Nothing. But I don't think it's going to fully take you where we want to go. Something else. Let's see your hand. Yes.
Move the 4x to the other side.
All right. Let's move that 4x over. Looks like I always want a 0 on one side. You notice that? Looks like when I get these crazy problems, I want a 0 on one side. Now what? Factor. Do these two have a common factor? What, a common factor of x? Take that out, you have this. And guess what I'm going to do? I'm going to apply sign analysis on this one also. So on the side here, I'm drawing a number line. And I guarantee you what was told me to me before with a square root, I guarantee you that's going to give me a partial answer there on this. Guys, if I split this up to see what my numbers are to work with, this factor says you got 0. This factor, when I solve it, gives me a 4. So I can do that one over there. So just got to place those two numbers on that number line. They are not to be included. Can anyone tell me why they're not to be included? Why did I not darken him one maybe? Why are they not included? Why did I place an open circle to show? Don't include those numbers, Professor. Those numbers are not part of the answer. What tells me they should not be included? Yes?
Because they're not equal to.
Now, I don't see the equals mark. It did not say greater than or equal to. Okay, it's straight answer. Now here we go. Sign analysis. I love sign analysis. Here we go. You get to test. You get to choose a number. Out to the left of 0, I don't care what you try. We'll try negative 1,000. In between, I'm going to try 3. Out to the right of 4, I'm going to try 50. But if you see one of these, you've got to show your numbers, your choice. Now, what am I going to do? You said, negative 1,000, Professor, are you nuts? Yeah, all I'm going to do is go back and quickly plug in, right here, If I replace x by a negative 1,000, that's a negative. Our next factor, if I replace x by a negative 1,000, that becomes what, negative 1,004, still negative. And what's a negative, times a negative will give me?
Positive.
Positive. Now please tell me, does this symbol imply that's what I'm looking for? Am I looking for a positive? It's greater than 0, say positive. It says you have discovered immediately an answer. Part of the answer. I've seen some of these where the entire number line works. Okay, in between we'll try 3. 3 here, replace x by 3, of course that's positive. 3 subtract 4, that's negative, negative 1. And altogether that gives me a negative, which I cannot use here. Out to the right, I'm trying 50. Replace x by 50, which is positive. Second factor, 50 subtract 4, that's 46, that's positive. And that's exactly what I'm looking for. I now have this. Also works. And there's your answer, visually, just by testing. It's called sign analysis. I love sign analysis. They use sign analysis a lot in calculus. Now though, I'm going to be asking you, after you do all this, tell me the answer in interval notation. Guys, looking at this, my final answer in interval notation, we said this interval works. Let's get this one out of the way first. Anyone tell me what that looks like written in interval notation? Everything to the left of 0. Negative infinity up to what?
To 150.
Is it there? Is that it? Negative infinity up to 0. Now, I have another piece though. Now, usually in math, when they ask you, or you see another piece, they love to use this symbol. A U like for union, to show you there's another piece. You're not finished. Union that with. Like a U there. The other piece is down here. How does this one that would look like 4 through infinity? It brought that in interval notation. Everything to the right of 4. Final answers, both of these. This is your final answer right here. Using sign analysis. Now, if you have a problem on the exam or the quiz where sign analysis would be used, I'll on the side there say use sign analysis. So you're not going to get into some kind of a routine that may take you elsewhere. I'll say use sign analysis. That square root did give me partially the answer. Guys, any concerns there? No. Okay, what's the last one?
X squared plus 2x plus 4 is greater than 0.
Oh. Who would like to be exempt from the quiz tomorrow? Wouldn't that be nice? After the quiz, I'll pass out the quizzes tomorrow, and all of a sudden you get to get up and read with a smile on your face. Wouldn't that be good? You're exempt. You're exempt. I see those hands. Well, I'd like to be exempt, Professor. Well, we've got to solve this last problem. Now, she's going right to me. She says, this is the last one. I saved it for last, for a reason. Here it goes. But based on what I'm hearing from this class, I think I may get the correct response. Read that to me one more time.
X squared plus 2x plus 4 is greater than 0.
Now, I started to say whoever could get that to work out within the next 2 minutes and give me an answer, I would exempt you. But darn it, Mr. Parks already sent the answers out. And some of my students have looked at his solutions, or could quickly look at his solutions now. So I'm going to not do that. Okay, here we go. The last one she gave me, this one, I factored. Oh, here's a nice one here. We did this one, it factored nicely for me, and I used sign analysis. I love sign analysis, I factored. Since this is the last one of the section there, I'd like to do the same thing here on this one, if I could, that I did here. And get my 2 numbers, place them on number line, beautiful, and start testing. What's the issue? Go for it.
Discriminant's negative.
Well, yeah, hang on, okay, you got, using the word discriminant. Tell me more.
Does it factor?
It's not gonna factor. This one I say for last, it's not gonna factor. You think I create these handouts just for fun? No, I get it's the level. I look at what I'm doing there. This one does not factor. The other's factored. Now, if I can't factor it, here we go back for a quadratic. This is a quadratic. You have options. You can use quadratic formula, or if you're ambitious, complete the square. I have students right now who still complete the square rather than use quadratic formula. I'm gonna use quadratic formula myself. Here we go. So guys, the best I can do here, we'll not factor, let's use quadratic formula. X is equal to -2 plus minus, I'll do it quickly. Square root, we end up with a 4 for b squared. Subtract 4 times a times c all over 2. You can quickly do that yourself. I put my numbers into the quadratic formula. If I have the numbers correct in there, -2 plus minus, I think underneath that square root is 4 subtract 16, which I think is -12. All over 2. Yeah, my student in the back. Clever. What must I do if I see a negative underneath a square root? What must I do?
No solutions.
Know what type of solution?
Real.
Real solution. So you got to now imagine. These aren't going to be imaginary numbers. We have not dealt with imaginary numbers yet. Imaginary. And what was that symbol representing an imaginary number if we run into it? I. That's what this would be. It'd be crazy. I'm not going to deal with I right now. So you may say, Professor, I'm going to just shut down. There's no answer. I'm saying we're not going to deal with I right now. I'm not going to go into imaginary numbers. It's not a real number for sure. But, this says, look at this, guys, as we close down. If it were this, and equals not greater than 0, like was given to me, you would close down. You'd say no solution. Professor, you haven't shown imaginary numbers yet until another chapter. So right now, no solution. But this was what was given to me. I think it was greater than 7. Now, even though this comes out to be negative underneath here, which means stop, you've got issues. I see right now just standing here. I see an answer like 0. Could x be 0 and satisfy that inequality? If I replace x by 0, 0 squared plus 2 times 0 plus 4 gives me a 4. Is 4 greater than 0? Yeah. 0 is an answer. Is, for an example, 2 an answer? If I just randomly choose 2. 2 squared is 4. 2 times 2, 4. What's that? 8 plus 4, is that 12?
12 is greater.
Is 12 greater than 0? There's another answer. So there are some answers here. Don't just put no solution. There are some answers. I think 5 works. You replace x by 5 and you're patient. I think 10 works. There's lots of numbers that work. And you got to tell me in interval notation, where are those numbers located that work? And if you can, I'll write down, then we'll discuss this, and beautiful. Move on to something else here. I mean, he thinks he knows what that interval of numbers that works. Tell me what it is.
It's parentheses, negative, infinity, comma, infinity.
Oh, you think everything works?
Because it never goes below.
Wait, hold on. So you're saying no matter, Professor, stand there rest of the class and start putting any number you wish in there. He says everything's going to work. Even a negative number? Okay, at random, let me choose a negative number. He says, Professor, all numbers will work on this one. So the answer is everything. Negative infinities or positive infinities. Let me just randomly choose -5. -5 squared is 25. 2 times -5 is -10. So I got 25, subtract 10, that right there is what, 15? Then 15 plus 4 is 19. Is 19 greater than 0? Yes. I'll try just one negative number. Now, can anyone give me a number that you think would not work? Let me step back a little bit. can anyone find of all the numbers in the universe, a number, and I'll replace x by it, do my calculation, and it does not give me a result greater than 0. If not, I'll accept his answer. He's saying, Professor, all numbers will work here. Can anyone give me a number? How about square root 2? Would square root 2 work? I haven't tried square root 2. That's a number. That's a real number. I replace x by square root 2, guys. Here goes. I don't know what I put myself into here. Will all that business, even with the square root 2, will all that business on the left-hand side turn out to be a positive result? Yeah, because watch 2. That's positive. That's positive. Well, all those combine to a positive. Can anyone give me a number that would not work? Pi? You can try pi if you wish.
Square root.
I think pi works. Yes.
Extra one?
Yeah.
Is that one now?
Negative one?
A negative 1.
Yeah.
Just a plain old negative 1. Right here. Negative 1 squared plus 2 times negative 1 plus 4. That's 1 minus 2 plus 4. Is that 3 when you add those up?
Would it still be negative?
Is that greater than 0?
What if it was negative 1 like square root?
Go to it again.
Negative 1 square root?
Negative.
Because then that would be I imaginary.
Oh no, I got you. Nikki, she said, Professor, maybe put this in there. Oh, we got issues. We're looking for real numbers here right now. So we have not discussed imaginary numbers. So let's not use those eyes. Guys, can anyone give me a nice real number that you think? It looks like they're all working. Now, before I close this all down, what was your rationale to say all real numbers?
One, the discriminant was negative, so there was no x that crosses the x-axis, so that the graph always stays above the x-axis, so it always stays positive.
Okay. Hang on. Should that graph into a parabola? Should all quadratics graph into a parabola? Yes. Anyone remember from middle school, high school, kindergarten? What determines whether the parabola opens up or down?
Positive or negative?
The leading coefficient. If it's positive, it does what? It opens up. He's telling me, Professor, when it opens up, and you've already found this does not work out, it does not touch the x-axis. If it touches the x-axis, you have answers. This one's not going to touch the x-axis because I get imaginaries. He says it's going to open up. Now where it is right now, I don't care, but I know it's opening up, somewhere it's opening up, and then I'll have students say, wait, Professor, could it not open up down here? Why could I not place it down there? Because it would eventually, what? Extend up and what? Do what? Cross the x-axis, and this thing would have worked. This would have worked then. So am I guaranteed then, with his thinking there, is that parabola, wherever it is it always above the x-axis? Which means it's this. Is that true? Is it always above the x-axis? As it goes from negative infinity through positive infinity or not? Is that a rationale? You think so? Woo. Yes?
If the leading coefficient is positive.
If the leading coefficient is positive, that just says it's going to open up.
Exactly.
Exactly.
If it opens down.
Yeah, if it opens down, then, got you. If you did this, which we didn't, then that parabola would be doing what? Opening down. Now, if it opens down, would it cross the x-axis somewhere? I mean, I don't care where you place it. If it opens down, like here, would it extend on down and eventually intersect the x-axis? Would then that give me answers? This one will give me answers. In other words, this would have worked. I got you. Okay, so guys, that last one's a little strange. Looks like all the real numbers. You can sit there and think. I don't care what you replace x by. Looks like it's going to work. My goodness, are we finished with all those inequalities? Yes. Then all of a sudden you take the exam or the quiz and say, Professor, why did you give me this hard one here? I sort of followed you, but why'd you give me that difficult one there? These, I think, make pretty good sense, don't they, guys, whether we're doing these? Yes,
I
Nick?
got a little lost at the end, because you said like, this is like a rational group.
Oh, that, no, not on this one. The rational 0 is 0, yeah.
So like, if it's 0, that means, and it's positive, it's opening up.
Yep.
That means it includes all real numbers.
Yes.
Negative.
Yes. It's going to include all real numbers.
But that's only because it's 0 at the end.
Exactly, it's opening up. Guys, I appreciate you. We got that done. We said the breaks can be at what time, like 5 minutes or something from now? Did we say like what, 4:30? Was it 4:30? Not how o'clock was it?
But no, it was 4:30, I think. It was before 5 though.
It was 4:30.
And class closes down at 9, I think, right?
No. 5:50.
Yeah. Oh, 5:50. Not enough time in this class. Okay, it looks like my time's going right. I did what I had to do. I'm not finished yet, by no means. But at least I'm finished with the inequalities.
Yeah.
I think that what we did is enough for you to get a good grasp of, and you're gonna get a review. If we see all this on the test, we'll get a review of some more problems to try. A good grasp of what to do to solve an inequality. I will alert you, because sometimes you'll maybe not use your time wisely. If I don't let you know to use sign analysis, I'll probably have to type on the test. This particular problem, please use sign analysis. That means go to your number line and test and find the answer by testing. Okay? Yes?
Well, if it says, if you didn't state that